127, factoring polynomials, guys. You're going to see all the different types of ways to factor here, except for completing the square. We're going to do that one in a different video. Okay. Factoring using the greatest common factor. It's very simple. The greatest that these three terms have in common as far as a factor is concerned is not 2, but it's 4. So we're going to take out a 4. Then you take a look at the x's. The greatest that they have in common. Well, the greatest that you can take out is an x squared, so we take out 4x squared. Once we've decided that 4x squared is the greatest common factor, we then go ahead and divide by that greatest common factor. What are you left with? 4x to the 5th minus 3x plus 6, and bam, you're done. Okay, let's move on to the next one. Factoring by grouping. And what we would do here is we would group together. Now typically when you do factoring by grouping, you're going to look to do this typically when there are 4 terms, okay, or an even number of terms, because what we're going to do is we're going to group together the first 2, group together the next 2, and we look for the greatest common factor. In the first 2, you can take out a 3b squared. Now, hint for you to use, whenever the first term is negative, just take a negative out. It'll make life easier for you later on. We're going to have a 3b, and then what? Minus 5. Okay, now, this is a minus sign. Again, because it's a minus sign, we're going to take the greatest common factor out of this, which will be a 6. We're going to take out a negative 6. We're left with what? 3b minus 5. This was supposed to happen in this problem, although it didn't have to. It was just more or less kind of supposed to happen when you do these factoring by grouping problems. Now what you're going to do is we're going to take a look at this from a different angle. Now we have term number 1 and term number 2. They both have a 3b minus 5 in common. So we're going to take out the 3b minus 5. What are you left with? You're left with negative 3b squared and a minus 6. Bam, guess what? You're done. Factoring by grouping. Next one, factoring trinomials, where we're going to factor these trinomials basically by trying to reverse the process of FOIL. So if you want to go back to video 126, you may have to do that. We're going to reverse that process. What we're going to try to do now, guys, this is always a guess and check. It's very simple. It's very easy. People try to teach this different ways. If you know how to add, you know how to multiply, you can do this. Just concentrate. Okay? Now, typically what you want to do here is you want to do the opposite way of multiplying. So what we know about the first term is that in this first position, it's either going to be a 4x 2x combo or it's going to be an 8x 1x combo. That's how you're going to get that first term. How are you going to get this last term? Well, it ends up being what goes in here and there. It's either going to be 7 and 3 or 21 and 1. This is not tough. We know how to divide. We know how to multiply. So let's do this. Then, guys, it's just guessing and checking. It's that simple. So what we do is now 8 and 1 are spread far apart. So we may want to work with 4 and 2 instead. But here's the deal. Let's say you tried 8x and 1x. What you would do is you would put the 3 either here or here. I would probably try to put the 3 here. Excuse me, I put the 3 here and the 7 here. But it's not going to matter. Why did I do that? Because if I put the 7 here, it's going to get multiplied by 1. Put the 3 here, it's going to get multiplied by 8. Does this add up to negative 2? No. So therefore, this is not the correct answer. Now what you could do is you could try to reverse the 3 and 7, but that's going to make matters worse because the 7 is going to get multiplied by the 8 and make it 56. So we know that 7 and 3 does not work with 8 and 1. Then if you try 21 and 1, that's probably not going to work either, because if you put the 21 over here, that makes 168. If you put 21 over here, then you got the 1 here. That's still not going to be a difference of 2. So what did we learn? 8 and 1 doesn't work. Guys, this is not a tragedy. You just go through and you say, okay, well 8 and 1 doesn't work, so now I try 4 and 2. This is not a big deal. You don't have to get the right answer right away when you do a math problem. Mathematics is about making discoveries. We just discovered that 8 and 1 doesn't work. It's not a big tragedy. Now you try your 4 and 2. We're going to put our 7 and 3 here. Now if you couple the 7 and 3, again, whatever you put here, it's going to get multiplied by 4. I say we put the 3 here and the 7 here, because if you put the 7 here, you're at 28. We only want a 2. And as it turns out, this works out, because you have a 14 and you have a 12. Well, what kind of a 2 do we want? A negative. Therefore, you want a negative 14 and a positive 12. Therefore, we have just figured out that 8x squared minus 2x minus 21 equals 4x minus 7 times 2x plus 3. So this would be the factored form, and this would be the polynomial form. It's pretty simple. It's just guess and check. You just see how it goes. There's a couple ways to do these, but this is the best way. This is the easiest way. This is the way where you do it. You're going to understand how to do mathematics. You're going to get the right answer when you do these box methods and all this other stuff, but this, you'll actually understand mathematics when you do it. Okay? Next one. We got 9y squared minus 18y plus 8. Well, what we're looking at here, now one thing you want to check here is just see, are there any greatest common factors? No. None of these divide by 3. Well, one of them divides by 3. Do they all divide by 3? No. Do they all divide by 2? No. So you just go ahead, and again, it's guess and check. I'm going to go right for the 3y's and see if we can get an 18 out of this. Now, one thing to look at here, guys, which is different from the last problem. You have a plus sign here, minus sign there. What does that tell us? Whew. Minus for both. They both have to be a minus in order for this to work out. We're looking at 4 and 2 or 8 and 1. And you just go from there. You try to create an 18. I think if we did 8 and 1, I think that's going to mess us up. That's not going to get us. That's going to take us too large of a number, because 8 is already 24. Let's try 4 and 2 and see what happens. 6, 12, 6 plus 12, 18. So guess what? Whew. That's the factored form. All right. Next one. Again, greatest common factor? No. So we're going to try to see what we can do here. Let's try 3 and 3 again. So this time 3a and 3a. Now, you have a 2. We need to get a 4. If we put a 2 here and a 1 there, what's that going to give us? It's going to give us a 6 and a 3. Well, 6 and 3, that's going to either add up to 9 or subtract to get 3, which doesn't work for us. If we reverse it, it's not going to change matters, because guess what? Those are the same, so it's not going to change anything. So guess what? 3 and 3 does not work. Then we try 9 and 1. Okay? 9a times 1a. Well, we only have a 2 and 1. I think we have to put the 2 here and the 1 there. Well, guess what? 2 and 9 does not get you down to 4. Therefore, what have we just figured out? That this trinomial is not factorable. It's not that there's no solution. It's just that the trinomial is not factorable. For example, you could actually probably argue that this trinomial is referred to as what's called a prime trinomial. Okay? Like the number 12. Is 12 a prime number? No, because 12 can be broken down into 2 squared times 3. Okay, this is the prime factored form. But what about the number 17? 17? That's a prime number. Okay? There's not no solution to 17. It just cannot be factored. It's just 1 times 17. So we're going to continue this video. We're going to break it up into a couple parts. We're going to, just so, actually, you know what we'll do? We'll finish off these trinomials and we'll break it up into another video. Alright, here's a special case as it turns out. Because, now, you'll see this too when this pattern comes up, that you have a 9, a 12, and a 4. Whenever you see these two as perfect squares, you should be looking for perhaps a perfect square trinomial. Okay? Now, what we'll do is, because we have a perfect square, let's try it as 3xy and 3xy. Let's put a 2 and a 2, and then just see if we get a 12. And as it turns out, we do. Both as a minus. Then we're going to rewrite this as 3xy minus 2 quantity squared. This would be the prime factored form, just like we wrote here earlier with the number 12. We wrote it as 2 squared times 3. Prime factored form. This is the prime factored form. Okay? Next one. This is another trinomial. Now you can see here, and what we'll do is we'll do this one in the next video. But that'll be video 127 part B. This will be 127 part A, it looks like. Now, you have 2a plus 3 quantity squared minus 8 times 2a plus 3 plus the 9. Now, what you could do is you can think of this as being like a squared minus 8a plus 9, if you want to think about things that way. And we can basically call this part a. See how that works? Then what we could do is we could factor this as it is. And it looks like this is not factorable. Or is it not? Let's see here. 9 and 1. And we're not going to get this down to an 8, are we? What we'll do is this. Let's change that 9. Let's change that 9 to a minus. But let's just say, actually, first of all, let's address this. If it was just like this, we would say this is not factorable. Let's go ahead and change this 9 to a minus just to have some fun here, to work on a problem that I think that I probably meant to make that minus when I typed it up. So let's do that now. That'll make